Okay, this is my lecture for homework 1 for statistics. We'll go ahead and start this. I decided to do mine on t-tests, which was the first option, and evaluating those using SPSS, which is a software that I will get into later. I just wanted to start with that. We will go on. This is the outline I made. I'm going to start with going over just t-tests in general. I'm going to talk a little bit about what they are for, kind of how they work. I'll go over a couple of simpler examples. I wanted to go over a couple of examples that we did during the homework too, because I think those were useful. Even though that wasn't with SPSS, I wanted to touch on those as well, just to get another perspective on those examples. Yes, going to discuss t-tests in general, like I said, and then we'll go over SPSS. SPSS here, talk about how to perform some t-tests within SPSS, talk about the results of those t-tests. Yeah, should be a pretty good time. I didn't mention this. We're going to go over the different types of t-tests as well, because there's a couple different ones, and they have different applications and everything. All right, just to get started, we're going to go over what are the t-tests. This will just be some of the basic information at the start to understand what they are. First, I want to just talk about what they are at a basic level. T-tests are a statistical test used to compare the means of two groups, specifically talking about the means and the averages of these two different data groups. That can be used to determine quite a few different things. The main thing we look at typically with the means are the differences between them. The differences between the averages can tell us a lot of different things depending on what you're looking for in the first place, and we'll get into that in a couple of the examples. What the t-test does to the means is it tells us if they're statistically significant or not, and by that I mean whether or not they're likely to have occurred by chance. If they're statistically significant, then it means they're unlikely to have occurred by chance, like this says here. And then we can decide if there's a correlation between those groups based on the result of that calculation. And that can be useful for a variety of reasons, as you can probably imagine. So that's kind of the basic purpose of t-tests. We can move on now to a bit more specific information about them. On the surface, comparing the means of different data sets seems like a relatively simple task. You can kind of do it on your own as a human with common sense. With pretty good accuracy, you can kind of look at two different sets of small numbers and be like, okay, the average of these numbers is definitely more than the average of these numbers, or less, or whatever. And you can kind of form an opinion about the data based on those inferences. But it's a problem that starts to become a problem when you get to larger data sets, like I say here. Like you're not going to look at two lists of 1,000 numbers and figure out the differences between them or not. You might be able to do it for 10 numbers each, but not for 1,000, not for 100,000, nothing like that. Especially if the data isn't clear. Like, it might not be clear to you what it means at first, and a t-test allows you to give numerical values to that comparison in order to, let us see the differences as accurately as possible in order to do stuff with that information. As you could probably imagine, there's a lot of different comparisons we make, and we make those comparisons in order to make important decisions about certain things. And having tools like this is one of many, by the way. T-tests are just one thing that help us do comparisons of data. Those help us make the right decisions for certain things. Pretty helpful, for sure. That's kind of the general overview of t-tests. Now I wanted to talk about a couple of the different types. These are the two main types that we worry about. And it would be independent sample t-tests versus paired samples t-tests. And we'll get into each of those now. The first one is your independent samples t-test. That one is for when you have two data sets, as you do with all t-tests, but for when these two data sets are not related to one another. Specifically, what I mean by that is that each data set, the data in each set is not dependent on the data or test results from the other set, meaning the data you have there doesn't have any correlation with the other set. They're independent, as the name suggests. So you can kind of test them separately, but you want to have one test that does both, so you can get the results together, and so they mean something in a more concise way. All you want to do is test the differences between their averages and not how they affect each other. So you're just testing those specific aspects of each set. So with this first type, an example that is pretty common that I'm sure you've heard before would be to compare the test scores between two different groups of students. This can be any test. It doesn't necessarily matter for the purpose of this. But let's say they're all taking the same test. So the only difference between these groups are the teaching methods. So as I say here, one of the groups has received a new type of teaching method for whatever material they're learning. The other group received a more traditional teaching method. Traditional, you take that to mean whatever you want. It just means they received different ways of learning the material from different types of teaching. It's kind of easy to see here that the groups are independent. This one group's test scores does not affect another group's test scores. Like, it doesn't matter. They're completely separate people. They take the tests in separate rooms, I assume. The test scores of group 2 are not dependent on how the group 1 does on the test. They can do it at the same time, different times, it doesn't matter. They're clearly independent variables here. So that would be an example of something you use for an independent t-test, because the variables in the groups of data are independent from each other. This could be useful maybe if you're trying to decide what changes to make to each teaching style, or just choose one teaching style over the other. That's if you're looking at teaching styles. You could use this data for lots of things. But yeah, you can look at the differences of their average test scores between the groups, and that could tell you something about their teaching style, or the style that they got taught using, whether that's the new one's better or the old one's better. But a t-test could be used to compare that data pretty easily. That's our first type. I thought that was a pretty simple, easy to understand example about that. We can move on to our next type now. Let's see. Next one, would be paired sample t-test. So as you can probably tell, this is the opposite. This is when your two data sets that you have, sorry about that. Where did I go? Oh yeah. Okay. Sorry, I lost my train of thought. These are for when your two data sets are in some way dependent on each other. And you want the data to reflect that, or the results to reflect that, when they are related to each other in some way. In some way, the data from one set's dependent on the data or test results from the other set. Each data point could be compared to each data point of the other. They could have different types of correlation. You could do a different test on the first data set, and the second data set could be the results of that test, and you want to compare how the averages changed based on whatever you did the first data set. But yes, this type of t-test is when they are related to each other. You want to see how one data set affects the other, or you just want to compare the differences with them tied together. Yes. They're also called dependent samples t-tests because they're dependent on each other, like I said. Yes, I think that's a good summary of this type. Let's move on. I have an example, actually. Yeah, an example similar to the last one, just a simple example. This one could be, let's say you want to compare people's weights before and after a weight loss program. Unlike the students, these tests are being performed on the same group of people, just at two different times. And in this specific example, you want to see how the weight loss program affected their weight, and therefore intrinsically the data sets are entwined. The analysis of a person's weight after the program is dependent on their weight before the program. You can't decide how effective the program is if you don't know what weight they started at. Like, let's say they started at 200 pounds and they lost 20 pounds, and the result after is 180. You can say that the program was effective in letting them lose 20 pounds, but if you only know one of the data sets at a time, you don't know where they started or where they ended, so it's useless data. You need to look at these together. So it's measured twice. The weight's measured twice before and after the program. The groups are clearly related to each other. Therefore, a paired t-test would be quite ideal for this situation. Yes, I believe that sums it up. Those are the two different types of t-tests. They are used in different situations. Those are a couple of pretty simple examples of how those work. Let's move on. I think our next thing that I want to talk about is, since we've gone over them in the basics, we now looked at what they're used for, the purposes of them, the different types, how they work. And I want to talk about just the t-tests and how those work in general, more specifically. So how t-tests work. The t-test is based on the t-distribution, which is a probability distribution that's similar to a normal distribution but has heavier tails. The t-distribution is used to estimate population mean when the sample size is small or when the population standard deviation is not known. The t-distribution is based on that, the t-test is based on the t-distribution, which is similar to a normal distribution. When you perform the t-test, you calculate what is called a t-statistic, which is a measure of the difference in means between the groups relative to their variability. I talk a little bit more about variability later, but essentially what that means is that the data within each group might vary more than the other set. If you have a set of data that is numbers 1 through 10, it's 10 numbers long. All the numbers are different. The numbers vary quite a bit. They vary 1 each time. But if you have another set of data that's all the same number, it has no variance. They're all the same. So the t-statistic is a measure of the means between these groups, and it matters what the variability is, because that will affect the average. Yes, that is that. That's the basics of how it calculates that. And then the main thing we're concerned about here with t-tests is the p-value. It's kind of what we look at to determine statistical significance. Can't always say that, sometimes mess up. Statistical significance. The t-statistic, like I just mentioned in the previous slide, is used to calculate the p-values. The p-values represent the probability of obtaining a difference as large as the observed difference. So that's your confidence interval. It's your probability of achieving such a distance that you've seen in the test, or that you've seen in the data between the sets. Let's see. And then this ties into your null and alternative hypotheses. This is assuming that the null hypothesis is true. This is the probability of obtaining a difference if the null hypothesis is true, which, as we talked about in class, the null hypothesis states that there's no difference between the means, that there's no difference. So therefore, in contrast, the alternative hypothesis would state that there is a difference between the means. If this p-value that we're looking at is less than some predetermined level of significance, which typically is 0.05, and our p-value comes out to somewhere around there usually. If the p-value is less than that predetermined value, then that means that the difference of the means is considered statistically significant and the null hypothesis gets rejected because their difference is significant enough to say that the means are not the same. So our p-value is kind of one of the main results we look at when we're doing t-tests, and seems to work pretty well. It's kind of our main concern here. That's a little more about how t-tests work. So we talked about the different types. We can go to a summary here of t-tests. We talked about the different types. T-tests are used as a tool for comparing the means of two groups and determining if the difference between them is statistically significant. That's kind of the overall purpose in general. There's two different types. The choice between independent samples t-test and a paired samples t-test depends on the nature of whatever you're researching and your research question, and will decide how you interpret the results. So like with those two examples that I went over, we have our sorry, let's go back and check them out. We have an independent test. We use the results to like select between the two methods, maybe. Like we're comparing two different things, so we select between one of them as whichever the better option is with an independent test. And then with this test, you're analyzing some difference between like how one set was affected by the other. So definitely which one you use can totally affect how you interpret the results. And lastly, a bit more of that general information. The t-test is based on the t-distribution and involves calculating a t-statistic and a p-value to test the null hypothesis that there is no difference between the means. Yes, that is t-tests as a whole. Next, I went over a couple simple examples, but as I mentioned at the start, I want to look at a couple of examples that I have from the last homework we did that had t-tests on it, because I think that was a fairly useful thing to look at. So I'm going to pop on out of this show here, and we're going to come on over here. So this is our homework assignment 4 from the last class. Has all this information that I just talked about. These are our R scripts. I'll show you running that in a minute. So let's start here. This is our first example that we looked at a t-test for. Let's just read it. A shop that makes smoothie drinks uses a recipe for its banana smoothie drinks in which the drink is supposed to contain 10 grams of sugar. The drinks are produced by a special machine that adds the sugar in a container before it mixes everything. An employee is suspicious that the machine does not add 10 grams of sugar for each drink. If the employee here is proven right, the machine must be replaced. You store the level of sugar of 25 drinks in a variable called drink sugar. Here's that data that we used to test this. I put this in an Excel sheet, which is within this that this R script pulls from. So that's here, and that's all the same data as this. You have to do a test that can address the employee's concern. The test is to excuse me. The test is to tell you if the level of sugar is different from the approved recipe. So in this sense, the level of sugar and the actual level of sugar in the drinks is different from the proposed level of sugar of 10 grams. So we're going to use an independent t-test here because we're testing two different unrelated amounts of sugar. The sugar on the recipe does not necessarily depend on the sugar in the drink, and the other way around is true as well. So we're going to use an independent test here. Our null hypothesis, the average amount of sugar in each sample drink, doesn't differ. So it does not differ. The mean is not different than the required 10 grams, and the alternative hypothesis is the opposite, saying that it does differ. Here we got, here a single sample, same thing as an independent, would be the most appropriate because in this type of t-test, the average of one group can be compared to the average of the control or the set group as separate things. So these are comparing two separate groups here. So yes, sorry, let's see, where was I? Next here, part C. We're going to perform the t-test using R. So this right here, this is not using SPSS. I go over that next. This is just an example I wanted to show to give some more understanding about t-tests in general. Good, so this is the output of our test here, and I'll run the script after just to show you that it works. This is our R command for running the script. This is our variable. This is our thing to compare it against. So that's 10. This is a one sample t-test. We have our pulling our data. We print our t-value, df value, and here's our p-value. This is kind of what we're mainly concerned with. And the value we're going to compare our p-value to is 0.05. It prints out our alternative hypothesis here, which is the true means not equal to 10, which is what it would be if the null hypothesis was true. That's what I set up here. Here's our confidence intervals, and here is our mean. This is the mean it gets. So our mean here is 9.98. That's really close to 10. So we have our p-value here that's, as you can tell, more than 0.5. So because the p-value is more than 0.5, because it's more than 0.5, we're going to accept the null hypothesis saying that the sugar's correct. Like the employee doesn't need to be suspicious because it does the correct amount of sugar. So that's an example of running this t-test in R. 95% confidence interval with the calculate average right below it. It's within the range. The p-value is greater than the alpha value of 0.05. Because of these observations, we failed to reject the null hypothesis. So the machine is correctly adding sugar. So that's our first one. This is the R script for it. I'll go here and run. We can run this just to see. What did I do? Mess them up. Okay, well, this was something else I added just to plot some stuff about the sugar. That's not necessary for the t-test, or something extra I did. So, but here, if I just run the t-test here, these are the results of it. It's going to show what we looked at up here. Same thing. So here's our first example of a one sample t-test. Let's move on to the next one. Okay, so our second one here, I'll go ahead and read it. A chain of membership-only retail warehouse clubs is interested in knowing the impact of a discount program on their sales. To investigate the impact, the company decided to follow the daily sales of one of its shops. The management wants to know if there's a statistical difference between the average sales of the shop before and after the discount program was implemented. The company provides the daily tracked sales of the branch from 7 days before the program started in the branch. That's the variable for that, and then for the 7 days during which the discount program has been promoted to the statistician. Yeah, statistician. Cool. What type of t-test do we perform for that? So this one is a two sample t-test because the two sets of data, which are down here. Here's our two sets of data. This first one the second one is dependent on the first one. You want to see the difference of this set after doing something to this set. So because these are paired here, we're going to use a two sample t-test, two separate sample t-test. And we're going to set, this is something I discussed this is the variance. So this is saying that the variance in each data set is the same. And I had actually messed this up previously and had some help to fix it. I used the wrong type of t-test, so I was guided to make this equal to true. When we do this is our R script, I guess it's this whole thing. This is the R line for running the script for the t-test. Here's our data that we're pulling from. Here's the p-value for this. So notice this one is different. The p-value here is below 0.05. We're going to print again, look at our alternative hypothesis. The true difference in means is not equal to 0. So let me go over these again. I skipped these. So our null hypothesis says there's no meaningful difference between the average sales before and after implementing the program. So if there's no difference between the sales, if they're the same, we're going to accept the null hypothesis. If they're different, then we'll reject it and go with the alternative hypothesis, which is the opposite. So here we're just saying the means are not equal to 0. Here's our confidence intervals. And here, again, since we're doing two sets here, we want the means of both. We have our mean, our average of the first set and our average of the second set. What we can see here is that, and this is kind of close. It was close to 0.05. So they're different, but they're enough. They're only just enough different to calculate as statistically significant. So we have our two means here. They are different by about $50. And from these results, we can see that this seems to have worked. Yeah, okay. So this is below 0.05. And from these results, we can see that the average sales before is this, and this number is lower than the average of Y, which is the after the program, which has a value of this, which is about $50 higher. In addition to this, the p-value is less than 0.05, which suggests we should project the null hypothesis. This means that there's a meaningful difference between the two groups, or a significant difference. And I would suggest to management they should keep the program because they had higher sales. So that's an example of a two-sample t-test. Let's pop on over here. This is the same thing here. Let me run this again. So this is our second test. This one shows the exact same thing that I just discussed. Our p-value, which is important, our confidence intervals, and then the mean of each. So this tells you that implementing the discount program was significant enough to warrant keeping the discount program. Yes. So those are our two types of t-tests that we did here. I thought that was a good example. I wanted to show this in R because this is kind of what we've been doing all semester. I thought this was good. Even though I already turned this assignment in, I know this lecture is not about the assignment. I thought it was good examples of t-tests, so I wanted to include that. I think that's all I got for these here. We can pop back on over to the presentation. Back in here. Oh no, I started from the start. Okay, back to our examples here. Oh no, examples. So that was where we were. We're going to move on to our next one. Now we're going to talk about, now that we are good with t-tests, we all understand what they mean, how they work, what they're used for. We saw a couple of in-depth examples about them. I want to move on to SPSS, and that's the other part of this lecture that we're going to do. So SPSS in general, it's a software package used for quantitative analysis of a lot of different types of data. T-test is one of many things it can do. It stands for Statistical Package for Social Sciences, and social sciences is just one of the fields that this is used for, among many others like business analysis, and plenty more. There's lots of them where data analysis is important. Yes, SPSS definitely has a lot of stuff within it. It has lots of other statistical tests. I have trouble with that word, I guess. But t-tests are one of the many things it can do. So I wanted to go over those a little bit more in this context. Yes, I think that's a decent overview of what SPSS is. We can move on now. I'll show a couple pictures. The next thing we have here is performing our test, or our t-test, in SPSS. Sorry. Let's move on. We'll go through this step by step. The first thing we want to do, this is the interface of SPSS, just an example. These were a couple of data, just arbitrary data sets that I put in just for testing. They're pretty small, again, 10 numbers, so like you could probably see that the average of this set's going to be more than this set. But these numbers don't mean anything. They're just for this example. So yeah, you're going to start here. You're going to input your data. There's multiple ways you can do this. You can either type it in manually like I have here, or you can import the data from larger data sets, or however you want to do that. But once you have the data in, we can move on to the next step, which you're going to come up here to your Analyze toolbar of your window. We're going to move to the Compare Means section. And you can see here there's lots of different stuff to do. There's even ANOVAs and all the other stuff in here, but we're interested in these right here. So there's a couple of different ones. There's one sample independent, summary independent, and paired sample. The two we're talking about here are independent and paired sample. Those are the two types I've discussed already. So we'll look at those first. So we're going to go up here, select our compare means, and then we'll pick whichever one we want. For this example, I think I went with a paired sample t-test. So this will be the dependent one, the sample one, or the two sample one. This is what it looks like once you select that. Once you select that type of t-test, this interface pops up. So it'll show you, since our data here you can see is in two separate columns. You create a variable for each one. Each column of data is a variable. You take and drag over here just to set these. You set these. Got it. Okay, yeah. Okay, I got confused about what this said. You put these in different variables. You want variable 1 to be one column, variable 2 to be another column. But since they're paired, they go in the same pair. I thought for a second I made a mistake and I shouldn't put them here, but I'm pretty sure I'm good. You want them to be paired because that's the type of test we're doing. But you can do it for more than one pair, which is cool. So yes, you want to set these in their own pair, their own variables. And then once you have that all set up with your data and with your stuff, you're gonna press OK right here to run the test. Once you run the test, this is the results screen you're gonna get. This has lots of information on it. There's multiple different tables. We have quite a bit of stuff to look at here. Sorry, I skipped a slide. Something else I'll go over real quick. I don't have pictures for it. But here, if I select a one sample instead, you'll have to then select the variables you'll have to select the variables corresponding to the two groups you want to compare, which we did for the paired as well. And then you're going to select whether you want equal variance or not. And like I said before, equal variance just means that the variability between the two data sets is the same. If it's equal, it's the same. So we can set that or not set that, however you want to do that. I think in that example in the homework, I did set it to true. So yes, that's what that means. If you select a paired, you just get this interface and you press OK and you'll be good. So back to our results. Over here under the significant section is where our P's are located. There's the only difference between these. This is the one you want to look at because this is right around our value here. I think it depends on your set. But yeah, these are our two p-values. And this here is what you'll compare to your 0.05 level to decide whether there's significance or not. So that's kind of what you're looking at. There it is. That's kind of what you're looking at here. Here you have your confidence intervals. Let's see. Here's the mean as well of that. Oh no, here's the mean. Here you go. These are what you want. Standard error mean. Good. So this is all our information, all the information that we want from the t-test. A lot of the same stuff R shows, but this is specifically for this type of analysis. That's your how to do a t-test in SPSS. Your two values here are kind of what you're looking at. This is the process of doing it. Yes, I believe that's it. Yeah, so that's SPSS as a whole. We talked a bit about. I'm going to do a summary here. We will talk about SPSS. It's a large piece of software. It has lots of different statistical analysis tools. I think on it says its size when you download it is over 1 gigabyte, so it's got a lot of stuff in there for sure. Not just t-tests. You can use it for large data sets. Like I said, I only put numbers that were 10 or sets that were 10 numbers long, but you could easily do this for a lot more, and I'm sure a lot of companies do that. Could be very useful. And t-tests, and I'm sure a lot of other things were easy to perform for sure. Seems like a good software. I like it. Helped me understand t-tests and other stuff quite a bit more. I think that's pretty much it. I got through everything. We went over t-tests, went over some examples, talked about SPSS, and then integrated the two and talked about how to run t-tests in SPSS. I think that's about it. Thanks for watching. Thank you.